Good morning, everyone. Today we are going to learn some of the interview questions of VLSI DFT. So my first question is, what is lockup latch? So lockup latch is basically used to avoid loading and unloading issues by adding a half cycle delay. So it is inserted between two flops for which the clock is taken from the first flop. So for the lockup latch, the clock is taken from the first flop. So we have a two flops. If two flops are passage followed by negage. In this scenario, the passage followed by negage. So here, in order to avoid the data loss, we are introducing a lockup latch here. So in here, we are introducing a lockup latch. So this latch is connected with the previous flop. This latch clock is connected with previous flop clock. So if you connect that one if we have a different clock domains, so two flops with different clock domains, if you connect this lockup latch to this clock, again the problem will come. So I explained why this problem is coming, how we can rectify this problem. So I explained in my previous video. Please go through it. Now, the next question is, what happens if we have a positive triggered flops followed by negative triggered flop? This case, positive triggered flop followed by positive triggered flop followed by negative triggered flops. So in a single cycle, loading and unloading data happens. So to avoid this, we use a lockup latch and provide off cycle delay. So as to attain a good capture of data. So by providing this lockup latch, we can able to attain a good capture of data. So in lockup latch can inserted in queue to SI path. The next question is, if serial fails, chain test also fails. What is the reason? So the chain test is failing. The question is, chain test is failing. Chain consisting of scan flops, which are connected in series. The scan flops are connected in series to form a scan chain. So if serial fails, chain test also fails. Serial is failing, serial simulation is failing, then automatically chain integrity test integrity gets failed. So what is clock skew? Capture clock latency minus launch clock latency will give the clock skew. This one is a capture clock and this one is a launch clock. So the latency between these two is going to give the clock skew. Launch clock latency minus capture clock latency. Sorry, capture clock latency minus launch clock latency will give the clock skew issue. So what happens if we go on increasing the compression? Actually, if we increase the compression ratio, the number of scan chains are increased, coverage is decreases. So internal scan chains are increasing, then the coverage is decreased, and also atpg tool will generate the indefinite patterns. The number of patterns also increases. Next question is, which is same as at speed frequency or functional frequency or shift frequency? Which is same as at speed frequency, functional frequency or shift frequency? So at speed frequency is a functional frequency. Okay. What are scan channels? The external scan chains are called the scan channels. Actually, in EDT we have a decomposer, and this is a core logic, and this is a compactor. So these are the external scan channels and these are the external scan chains. So if you go with the EDT bypass mode, so EDT logic is not considered. So external scan chains like this, it will go like this. It will go. The internal these scan channels and these are the scan channels. These are the compression logic. So here we have a number of scan chains. So external scan chains are called the scan channels. These are called the scan channels. And next question is, what is contention violation? Contention violation. When a signal input is when a signal input is driven by two or more nets is called the contention. Suppose this is my bus and the signal input is this one and this is driven by two or more nets. So we call this one as a bus contention. So how to fix this bus contention violation? I made a separate video on this one. So with the help of OR gates and AND gates, we can fix this bus contention issue. By command format, we can fix this one as set Z handling. Can able to fix the bus contention issue. So I made a separate video for this one how to fix this bus contention. So please go through that video. Playlist it is there. If you have a two clocks with 55 megahertz, 1 gigahertz, which frequency you use for shifting and why? So this frequency is 55 megahertz and this frequency is 1 gigahertz. So this is a high frequency. So if you have an high frequency, the time period is very less. So normally this is the time period. So the frequency is high, the time period is very less. So maybe like this. So here one clock cycle and here the clock is toggling 4 times, 2 times instead of 1 time. The frequency is high, it is low frequency and this one is high frequency. So if it is toggling more times, so that during the shift, I mean testing, the entire circuit is in operational. Then the power dissipation is the clock is more toggling means the power dissipation is more. Also current, it will draw the more current that maybe leads to the burnage of chip. So to avoid that issue, so normally the shifting is going to happen at a low frequency and the capture in case of if we are going with at speed testing, the capture is going to happen at a functional frequency. So if you are with stuck at the shift and capture both are going with the functional frequency. So this is all about the interview questions of today. So we'll come up with new interview questions tomorrow. Please share and subscribe my channel.